Alright, welcome to 4.4. We are combining all the transformations that we've done so far together in this section. But again, before we do that, we're going to do a quick review here. Here's the question. It says, write the equation of the image of y equals 1 over x plus 3 after a vertical compression about the x-axis. So vertical compression by a factor of 0.5. So if it's a vertical compression, remember this is about a, and it's just going to be 0.5 because it's a compression by a factor of 0.5. Horizontal compression by a factor of 0.25. So this means, again, B will be then, if you recall, actually the factor should equal to 1 over B. Then you can solve for B. That's 0.25. B equals to 1. Divide both sides by 0.25. 1 divided by 0.25 is 4, so B is 4. Finally, reflection in the x-axis, that means all the y values will go from positive to negative or negative to positive. And therefore, A is not just 0.5, it's going to be negative 0.5. So we have both the values of A and B now. We can then apply those two into the function. Recall it was y equals A times f of bx. So this is the entire function f of x right there. So we're going to put a in the front. So y equals negative 0.5 of the function 1 over, now I see x. I'm going to replace x with bx. So it's going to be 4x. Oops, I still have plus 3 there. Plus 3. Okay. Now I'm going to rewrite the 0.5 as 1/2. So I can actually expand this. So this is going to be negative 1 over 8x. X being in the denominator, minus 3 over 2. That would be the new equation. Okay, that's the equation of the image graph. Okay, so hopefully you still remember what we learned last time, and that's the result. So here you go. We are going to start 4.4. It says, so far we've dealt with translations and expansions, compressions, reflections separately. If we were to combine these transformations, would the order of the transformations that are being applied make a difference? If you watch the previous lesson carefully, I think I gave you a preview of what's coming today. Yes, the order does matter because, like BEDMAS, we need to multiply before we can add or subtract. So it does matter. It makes a difference. And we need to, it's going to be the stretch. Okay, so expansion and compression, stretches first, then translation. Okay, when we talk about stretches, of course, this also includes the reflection, okay? Because they are, both multiplications, so they can be dealt in the same step. So stretches and reflections first, then translation. Okay, so multiply first before you add or subtract. Okay, so here we go. Here's the first example. I have labeled the points here already. It says sketch and label its image after horizontal compression by a factor of 1/2, and then 3 units right. So we are going to change x because the horizontal compression by a factor of 1/2, so it's just going to be 1/2 x. And then 3 units right, therefore for the x value, once we multiply by 1/2, we need to add 3. The y value will remain the same. Okay, so now I'm just going to multiply all the x values by half, by 0.5, or just divide by 2, and then plus 3, so we should get negative 1. Half of negative 8 is negative 4. Negative 4 plus 3 is negative 1. And if you do the same thing for the next one, half of negative 5 is negative 2.5, plus 3 is 0.5. You just keep going, you should get the following result. Okay, so this should be 5. And all the y values will remain the same because we didn't really do anything to it. Okay. Here are my y values. Okay, now I can plot. Negative 1 and 1 is right here. More. 0.5 and 2 is here. 1.5 and negative 2 is here. 4 and negative 2 is here. 5 and 1 is here. Now you can join them together. Here is your image graph. Okay. Now I will do something here that's not being asked. That is, well, what's the new equation, I suppose, right? So original equation is y equals f of x. Now after these transformations, well, then what happens? Well, because we have a horizontal compression factor of 1 over 2, so recall b, so factor is equal to 1 over b. Factor is equal to 1 over b, so I think it's clear in this case b is equal to 2. And then it says translation of 3 units right, therefore c has to equal to 3, right? It's going to be x minus 3. C equals to 3. Therefore, we can then write the equation, the new equation. It's going to be 2 bracket x minus 3. Okay? That will be the equation. Because if you haven't seen, I can't remember if I wrote this in the previous lesson. But this is the full version of it. Okay, this is the full version of it. Y equals a times f of b bracket x minus c plus d. So b is outside of the bracket. Okay, so be careful. The 2 is here, and then bracket x minus 3 because we're moving 3 units right. Okay, so that's the example. Hopefully that makes sense to you. If you think you're okay with this, try this one right here. You should pause the video and try it. Okay, so I'm assuming you're finished. We want to sketch and label the image after a vertical expansion by a factor of 2, which means a is equal to 2 here, and then a translation of 3 units up. Therefore, d is positive 3 right there. Okay, so that means x comma y will become, well, again, we didn't do anything with x, so x will just be x. Expansion of factor of 2, so that's going to be 2 times y. And then 3 units up, so plus 3. Okay, so maybe I'll write this down here. If we combine everything that we did, x comma y really becomes x over b, right? That's the translation, plus c. And the y value becomes a times y plus d. Okay, so that's what really happens right there. Okay, so again, a is 2, so 2 times y plus d, which is 3 right there. So I'm going to copy down all the x values because they have nothing. Y values, I'm going to double them and plus 3. Okay, so negative 1 times 2 is negative 2, plus 3 is 1. 2 times 1 is 2, plus 3 is 5. That's going to be 7, and this is going to be 5 right here. So I can plot these 4 points. Negative 4 and 1 is right here. Negative 3 and 5 is right here. Negative 1 and 7 is right here. And finally, 1 comma 5 is right here. So there is my new graph. Okay, so then again, if the question asks you to write down the equation of the image graph, well, so again, we are just going to compare with a times f of b bracket x minus c plus d, and then just plug in the values, right? A is 2, so it's going to be 2f. B is 1, C is also 1, so we don't need to do anything there, so just f of x, because we didn't do anything with B and C, or horizontally, and then plus 3 at the end. Okay, that's it. Hopefully that's what you got. Here's another example. So now nothing is told, I guess, but rather we are given an equation, and we just really need to state what these values are, A, B, C, D's, and then apply or describe the effects. So in this case, A is 2, therefore vertical expansion. B is 1/2, so it's also vertical expansion by factor of 2. It's 2, because it's 1 over 2. 1 over B, I'll write that out actually. 1 over 2. It's actually 2. C is negative 3, so be careful because x plus 3, and again we are comparing with a f b bracket x minus c plus d. We're comparing with x minus c, but this is x plus 3. That means c is negative. Okay, d is going to be negative 5. So this is horizontal translation, 3 units left. This is vertical translation 5 units down. Okay, so already here, yes, x comma y will actually becomes, this is a little bit longer, x horizontal expansion by 2, so times 2, and then 3 units left, so minus 3. For the y values, expansion by 2, so 2y, 5 units down, so minus 5. So these are the operations that you need to apply to these points. Okay, so for x, I need to double and minus 3. So negative 2 times 2 is negative 4, minus 3 is negative 7. That's going to be negative 3. 2 times 2 is 4, 4 minus 2 is 1. For the y values, I need to double and minus 5. So 2 times 2 is 4, minus 5 is negative 1. This is going to be negative 9. And the last one is going to be negative 1 again. So now I can plot. Negative 7 and negative 1 is right here. Negative 3 and negative 9 will be somewhere here. Oh, I missed it. Right here. And then positive 1, negative 1 is right here. So there is my parabola. Image graph. Okay. Domain will not change because it was all real numbers. It will keep it, or it will stay as all real numbers. Range that has changed. Now we have a minimum of negative 9. So y is greater than equal to negative 9. Okay. There's the practice question for you to try. Again, I have the points table for you. Notice how we also have two asymptotes, vertical and horizontal asymptotes. So I also labeled them out. And good luck. Okay, so in this question, notice this is not in the form that we wanted. So what we should do first is to move this minus 3 over to plus 3 on the right. So now we can figure out what the values of the ABCs are. So A is 1, B is 1/2. So nothing changed here vertically in terms of stretches. However, because B is 1/2, we know this is horizontal expansion by a factor of 2. Okay, because 1 over 1/2, which is 2. C in this case is 1, so this is horizontal translation 1 right. For D, the value of D is positive 3. So we are going to have a vertical translation 3 units upwards. Okay, so what this is telling me is that x comma y will then becomes, so for the x, horizontal expansion by 2, so 2x, 1 unit right, so plus 1. Vertically, there's no vertical stretch, so I don't need to multiply anything. But we do have a vertical translation of 3 units up, so plus 3 there. Okay, so now let's go with the points here first. X, it's going to be double and plus 1, so negative 1 times 2 is negative 2, plus 1 is negative 1, 1 times 2 is 2, plus 1 is 3. Y values will simply plus 3, so that's going to be a 2, and that's going to be a 4. Okay, now, because this is y, right, it's y equal to 0, so you just apply this one right there. So it was y equal to 0, now it's going to be y equals to 3. It was x equal to 0, so now we just apply the x transformations here, so it's going to be x equals to 1 now. Notice that the multiplication here doesn't actually change your asymptote. It's the translation that changes the location of the asymptotes. Okay, so now we can graph this. Y equals to 3 is our horizontal asymptote right here. Vertical asymptote x equals to 1, that's right here. Our new point, new A, the A prime is negative 1 comma 2, which is right here. And remember the graph goes towards the asymptote, as we can see from the original graph. B prime is 3 comma 4, that is right here. Here's my graph, like that. Okay, now for the domain. So, well, then I guess we just need to restate it. It's now x can equal to 1, but it could be anything else. the range, it's gonna be y k I equal to 3. Again, I just took them basically from the asymptote, okay? But it could be everything else, anything else. All right. Hopefully that's what you got, okay? Slightly challenging because of the -3 there. There's a real challenge right here, okay? So we want to use the graph of y equal to root x, which I have drawn here, and there's the table value right there. We want to use this to draw this, okay? So be careful. There's a little trick to it. Not just moving this -1 to the right. There's another part I need to watch out for. Okay, so maybe try this with pencil, and I'll show you how to do it once you're finished. Okay, so hopefully you tried, and hopefully this is what you did, okay? Again, we are always going to compare it with y equals a times f of b bracket x minus c plus d. The difference is this. Definitely need to move to the right. The other difference is this. Inside the function f, it's b times, in brackets, x minus c. There's no brackets there. So what you need to do first is factor -2 out, and then +1 at the end. And notice how I factor -2 out, and therefore this is x minus 2 now. Okay, so that is important. If you don't do that, your graph is going to be incorrect. Okay, so be careful, be careful, be careful. That is one thing that students tend to forget. Always, always factor out the value of b first. Okay, so now we can state our ABCDs. A is simply 1, B is -2. Therefore, this is going to be a horizontal compression by a factor of 1/2. But because of negative sign, it's reflected over the, which axis now? Y-axis. So really, just multiply by -1/2, you'll be fine. C is +2, therefore we have horizontal translation. Oh my goodness. Horizontal translation. 2 units right, and then we have the value of d being 1, so this is a vertical translation, 1 unit up. So x comma y, well, x will be -1/2 x, because we're moving 2 units right, so +2. And for the y value, we are just going to move up by 1, so it's just going to be y plus 1. Okay, so now we're going to apply this to our table value, so we get our x prime and y prime. So for the x values, I'm going to times by -1/2 and then +2. 0 times anything is 0, +2 is 2. -1/2 times 1 is -1/2, +2 is 1.5. -1/2 times 4 is -2, +2 is 0. For the y values, I simply just add 1, so 1, 2, and 3. Now, 2 comma 1 is right here. 1.5 and 2 is here. 0, 3 is here. There's my graph. Okay. And what are the domain range for this new graph? Well, the domain is going to be x has to be less than or equal to 2, because it's on the left side of that. And the range will have to be greater than or equal to 1. Okay, so that's the new domain range. For the original domain range, I'll use blue. You didn't ask, but I'll show you anyways. I mean, I'm sure you can get it too anyways. It's greater than or equal to 0 here, and range will be also greater than or equal to 0. You see it actually changed quite a bit. Okay. All right. I have one more example to show you, and then you have one more practice question to do. Okay. Here we go. So this question, again, we've seen this in the previous lesson, but then it was just with stretches, right? Just expansion and compression. But now I'm going to incorporate the translation as well. Okay, so let's see. It says the graph of y equal to g of x is the image graph of y equals to f of x. So the red graph is g of x, and the black or the thinner one is f of x after a combination of transformations. Corresponding points are labeled, right, and then it verifies an equation for the image graph in terms of the function f. So again, we have 2 points, b 0 0 becomes b prime 1 comma 2, c 1 1 becomes c prime 2 comma 4. So I think I showed you this earlier. recall x comma y after a series of transformations, this actually becomes x over b plus c over ay plus d. This is all the transformation there is, okay? So recall these, or this is the original x, and the x over b plus c will give you the new x value. So from here, we have the original x value of 0. Once you divide that by b, the value of b, and add it to the c value, this should give you the new x value, which is 1. Okay, so that's the equation we can come up with. We can do the same thing with the second one here. 1, that's the original x value, divided by b plus c should give you the new x value of 2. Okay, so I'm going to go ahead and solve this equation right here. Now, this time you actually get lucky because it's 0 over b. Remember, 0 divided by anything is 0. So really, you have 0 plus c is 1. Therefore, c has to equal to 1. Okay, you don't always have, you're not always this lucky. I'm just telling you right now. In the next exam or the practice question, it won't be like that. So what you have to do is you got to treat this as like a system of equations and solve by elimination. So if you subtract them, c minus c will be 0. Then you're left with just one single variable. Okay, so that's what you would need to do if no special case like this happen. Okay, this doesn't happen very often. Okay, anyway, so c is 1. Now once you have c equals to 1, then you can solve for b by plugging 1 into one of the equations here. Now it doesn't really make sense to plug into the first equation because, I mean, b could be anything because 0 divided by b is 0 anyways. So we have to, in this case, plug into the second equation. We have 1 over b plus 1 has to equal to 2, which means 1 over b is equal to 1. Well, I guess b has to equal to 1, right? Because 1 divided by 1 gives you 1. These are your C's. Now I'm going to do the same thing with the y values. I'll use green this time. So for y values, here is the transformation, ay plus d. Okay, so I don't know what a is, but my original y value was a 0. If I add that to the d value, that should give me my new y value, right? So this becomes that. And I'm going to do it again for the second set of points. So a times the original y value of 1 plus plus the value of d, that should give me the new value of y, which is 4. So again, a times 0, that's simply 0, which means d has to equal to 2. And if I plug in 2 into the second equation, a times 1 is simply a, plus 2 equals to 4, therefore a equals to 2. So we have all the values of a, b, c, d. Now we just need to plug it. Remember, y equals a times f of b, bracket x minus c plus d. Now we just need to plug them in. A is 2. A is 2. F bracket b is 1. So we don't really need to write 1 because it doesn't do anything. X minus c, x minus 1, that part you need to do. You need to write it down because again, b is multiplication. Multiplication of 1 doesn't do anything. Just stays. Plus d, so plus 2. And there is your transformation. Okay, so there is the last practice question for you to try. I have the points labeled for you. Give that a try and see if you can do it, okay? I'm going to take a break, have some water. Good luck. All right, so again, you need to use the fact that the x comma y really becomes x over b plus c, ay plus d. Okay, so original x value was 1. 1 divided by b plus c gives you the new x value of 0. I got to do it again for the second point. So negative 2 divided by b plus c equals the new x value of negative 3. And again, this time we are not so lucky anymore, right? This is no longer 0, so what we need to do, like I told you earlier, we need to do system of equations. Solve by elimination. C minus c gives 0, so we eliminate one of the variables. And then we have to do 1 over b minus negative 2 over b equals to 0 minus negative 3. 1 minus negative 2 is 3. That's like addition. Equals 0 minus 3 is negative 3. You can solve for b. I think this one is rather clear, but you can always cross multiply and solve for b. but I think in this case it's clear b has to be -1 because 3 divided by -1 is -3. So now we have b solved, then we can plug this into the original equations, either the first one or second one. I'll plug into the first one because it's a bit smaller. 1 over -1 plus c is 0, that's -1 plus c is 0, therefore c has to equal to 1. There. Okay, c equals to 1. Okay, so now I have both b and c solved. Now I can move on and try to solve for a and d. So that has to do with our y values. So now, again, a1 plus d, right? So original y value becomes the new y value. So a times the original y value plus d should give you the new y value. A times the original y value plus d gives you the new y value. Okay. Now I can solve this. This, again, I need to subtract, just like what we did with b and c. D minus d is nothing, right? So it's just gone. So we eliminate one of the variables. That's a times, which is a minus 0.25a equals 3 minus -1.5. This is 0.75a equals 4.5. We can solve for a. Is this right? 25. 25, -1.5, yes, 1, 3, -3. Okay, looks fine. Okay, so now we just solve for a by dividing both sides by 0.75. You should get, I don't remember what it is. 6. A is 6. Okay. Now once you have a solved, then you can plug into. Okay, I better double check. This doesn't sound right to me. Okay, before I move on. Okay, let me see. A is 1 comma 1 becomes 0 -3. Yes. And -2, 0.25 becomes -3, -1.5. So a times original y value of 1 plus d gives you new y value. Yep. Okay, well, I guess looks fine. Oh, I found my mistake. Okay, that's better. It was -3, not +3. My bad. So this should be -1.5. -3 plus 1.5 is -1.5, and therefore a is actually -2 only. Okay, that's better. Okay, so a is -2. Now we can plug into, I'm going to do in the first one because it's just integers. That's -2 times 1, which is -2, plus d equals -3. Therefore, d has to be -1. So now you have all the values of a, b, c, d solved. We can then just plug into the equation a times f of b bracket x minus c plus d. A is -2. F, b is -1, x minus c, so x minus 1, plus d, which is -1. And there is your final answer. Okay? That's it. That's it for the transformation, really. Next lesson is about inverse, not really about transformation anymore. Well, it is kind of. It is a transformation still. But this right here is basically the summary of this unit, at least for what we've learned so far, okay? So I'm not going to go over it because it's really everything I've said in today's lesson or in the previous lessons, but definitely it's a good summary for you to read it over. Yeah, if you have any questions, let me know. Otherwise, good luck with your work.